Good afternoon. My name is Dwayne Brown from the Office of Communications, and welcome to NASA headquarters. NASA rang in 2012 with twin spacecraft being placed in orbit around our moon. And not only will you hear the current status of the twins, but also upcoming plans for science operations. And for the grand finale, the announcement of new names for the spacecraft as a result of a nationwide student contest. We will have brief remarks from our participants here in Washington, then go to the phone with Sally Ride, America's first woman in space and president and CEO, Sally Ride Science, San Diego, will take us into the grand finale. Let me introduce you to today's participants here on stage in the order of their seating. First, Leland Melvin, Associate Administrator for Education, NASA headquarters. Maria Zuber, GRAIL Principal Investigator, Massachusetts Institute of Technology, Cambridge, Massachusetts. Jim Green, Director, Planetary Science Division, Science Mission Directorate, NASA headquarters. We'll start with Leland, then Jim, and then to Maria. Leland?
Thanks, Dwayne. I'm really pleased to be here today to share in the next step of the GRAIL mission and learning the names that the students have chosen for the twin spacecraft. NASA's science and education programs are perfect complements for engaging America's students in STEM, which is science, technology, engineering, and mathematics. NASA's scientific missions and the exciting discoveries that they reveal are wonderful catalysts for getting students interested in studying science, and it's really cool. I mean, like, really cool to study science. I was talking to Maria a little bit earlier about how my mother gave me a chemistry set when I was a young boy, and this was before OSHA got involved with chemistry sets, but I mixed these two dissimilar chemicals and created this fantastic explosion in my mother's living room. So the coolness led me to become a chemistry major. So we have to do more things like this to get kids inspired in doing cool stuff. But science has always been an important component of NASA's education program, and I think it will be featured even more prominently now that we're in the post-shuttle era. In November, NASA Education joined our friends in science in celebrating the launch of the Mars Science Laboratory and the Curiosity rover. The name Curiosity was also chosen by a student, Clara Ma of Kansas. By engaging students in the interactive learning tools developed for this mission, we're really taking them along on the journey. This mission even captured the attention of entertainer will.i.am. He joined us for the launch and has restated his commitment to helping students get excited about robotics and technical subjects. We're happy to be working with him so that he can do more of that. Science is exciting, and the GRAIL spacecraft will no doubt offer many opportunities for students to learn more about Earth's only natural satellite. I am really delighted to work with my science colleagues to my left to inspire and truly inspire the next generation of explorers. Thank you.
Thank you, Leland. Jim?
Well, you know, this has just been a tremendous year and a half for planetary science. Over that time period, we flew by 2 comets. We put 2 spacecraft in orbit around bodies in our solar system, Messenger around Mercury and Dawn around a fabulous asteroid called Vesta. We also did 3 launches. We launched Juno to Jupiter. As Leland mentioned, MSL, or the Curiosity rover, is on its way to Mars. And of course, the GRAIL mission in September. Now, since that time, since September 10th, the 2 GRAIL spacecraft have made it to the moon, and it's going to open a new era for us. It's really going to be a new moon. It's going to look at the moon in ways we've never seen before. And to give you an update on the health of those spacecraft and where they are, Maria?
Great. Thank you very much, Jim. Okay, if we could run the first video. All right. On New Year's Eve and New Year's Day, the sparkling cider was popping out at the control rooms in the Jet Propulsion Laboratory in Pasadena, as well as in our control room at the spacecraft contractor Lockheed Martin Astronautics in Denver. On New Year's Eve, the GRAIL-A spacecraft inserted successfully into lunar orbit, and then just in time to take a little bit of breath, 25 hours later on New Year's Day, GRAIL-B inserted successfully into lunar orbit. We've been busy since then. The two spacecraft have each gone through a series of 3 main engine maneuvers to reduce their orbital periods. They both started at 11.5-hour orbits, and now GRAIL-A is orbiting it with a 3.7-hour period, and GRAIL-B is at a 3.9-hour period. GRAIL-A is about 93 kilometers above the surface of the moon. GRAIL-B is 109 kilometers above the surface of the moon, and the two spacecraft will undergo further main engine maneuvers to get them down to their mapping orbit of 55 kilometers. So at this point, both spacecraft are still being operated independently, but then we're going to line them up, and they'll begin mapping the moon in early March. So you can see here in this animation the first spacecraft there being accelerated due to that mountain there on the moon, and it gets a larger distance from the second spacecraft, and then once the second spacecraft is affected by that gravitational mass, it catches up to the first spacecraft. So these two spacecraft, they're going to be in orbit, the one behind chasing the one in front, in a polar orbit while the moon slowly rotates beneath them, and in that way we will map the moon, determine the gravity field, and gain in our understanding of the inside of the moon. If we could have the next slide, please. So mapping of the moon will begin in early March, and you see in this still here the two spacecraft side by side in their launch configuration out in the clean room at Lockheed Martin. These two spacecraft, as I said, are now in lunar orbit. We were so busy in the design and getting these two spacecraft launched on time that when we gave them names of A and B. And that isn't too creative, and so we asked the youth of America to assist us in getting slightly better names, and we held a nationwide contest. We had, if we could go to the next chart, I think we'll have here. We had over 11,000 students involved in the naming from 45 states and several territories and provinces. All of these students wrote essays. There was a very competitive competition, and the students really stepped up and made a very difficult decision for us. So to talk a little bit more about the program and the contest, and also GRAIL's education and public outreach program, I'm going to turn it over to Sally Ride.
Dr. Ride?
Thanks, Dwayne. Thanks, Maria. I'm really proud to say that GRAIL is the first spacecraft mission to carry instruments that are entirely dedicated to education. Each of the two spacecraft carry dedicated cameras that will be operated by students. Maria and I designed an education program using these cameras that will rocket over 200,000 elementary and middle school students to the moon. The program's called MoonKAM, that's MoonKAM with a K, and it lets classrooms around the country, and in fact around the world, control the cameras on the GRAIL spacecraft. Students own these cameras. They'll decide what pictures to take, then they'll use their pictures, and if they like, pictures taken by other schools to study the moon. We already have over 2,100 classrooms signed up, representing over 150,000 students. And by mid-March, when the mission starts, we expect over 3,000 schools to be participating. Now, the classroom that won the naming contest is one of those already registered for MoonKAM. We're about to introduce the winning classroom to unveil the names of the GRAIL spacecraft. But first I wanted to announce that in mid-March, they'll have the honor of being the first school to take photos of the moon with the MoonKAM cameras. Now we'll go live via Skype to Bozeman, Montana. And it's my pleasure to introduce fourth grade teacher Nina DeMauro. Her class at Emily Dickinson School in Bozeman submitted the winning entry. Nina, congratulations.
Oh my gosh, this is unbelievable. First of all, welcome to our classroom at Emily Dickinson School in Bozeman, Montana. This has been just a phenomenal experience. We're so excited. It's an exceptional honor. We can't believe it's actually happened to us. We're so thrilled that our names were chosen for GRAIL-A and B. We hope, but we didn't know that this. We're so anxious now to share the names with you, but we'd like you to join us in a class cheer. Give me an E. E. Give me an F. F. Give me a B. B. Give me an L. L. Give me a B. B. Give me an O. O. Give me an N. N. Give me a W. W. What have we got? Ebb and Flow. Hear you. Thank you for the honor of being the first class to use the MoonKAM in March. We can't wait. We're looking forward to it. Thank you.
Let's give them a round of applause, ladies and gentlemen. Maria, I would say they're a little excited. Just a wee bit.
I hope they apply to MIT someday. So,
And before we open it up for questions, Maria wants to give you some more details on the winning essay. Maria?
So I didn't even know that fourth graders studied gravity, but this class full of students wrote a very clear essay, obviously learned something about the GRAIL mission. They noted the fact that GRAIL is going to be studying gravity on the moon, and that the effect of gravity on the Earth is seen every day in terms of tides that we have on the Earth. So, so they chose Ebb and Flow because it was the daily example of how the moon's gravity is working on the Earth. And I thought that that was, although it was very simple, Sally and I were extremely persuaded, as well as all of us on the team, about how sophisticated the thinking was that went into that selection by the students. So congratulations, they're students. So.
Yes, congratulations again, and Ebb and Flow. Congratulations, Emily Dickinson, and the teacher and the students. This is what NASA is about, inspiring the next generation. No better way to do it, ladies and gentlemen. Congratulations. Okay, now we're going to wrap up here soon, but we're going to see if there are any questions here in the audience. Is there any questions? Wait for the mic and identify yourself, please.
I'm from Global Brazil, and would like to understand if the separation of the two aircraft, when used with the cameras, produce depth of image.
Oh, so you're essentially asking if we can do stereo
Right.
with that. Actually, I don't know the answer to that. I suspect that the spacing between the two spacecraft may be too great for that in their regular mapping configuration. But that's something that we could check. You would need to have both spacecraft viewing the same object on the surface at the same time. And I believe that they're probably, from a 55-kilometer orbit, given their spacing, that it's probably too great.
If I could follow up, they will not be flying exactly over the poles, but close to the poles. Another aircraft have detected what is possible, possibility of a large increase in the amount of what could be water even 2% of every shadowed surface on the poles. Would those two aircraft kind of shine any more information on that?
Okay, so the question was about water at the lunar poles. Okay, so the lunar poles are being monitored with the Lunar Reconnaissance Orbiter spacecraft, which is orbiting the moon and collecting data right now. And we have taken topographic measurements which have allowed us to map the inside of lunar polar craters. And we've also taken images and also spectral information to tell us composition in the vicinity of the lunar poles. So the craters that have hydrogen deposits that may be water ice are in permanent shadow. So a visual image will not reveal that because you can't see into those dark craters. Okay. However, it is actually possible that the size of the craters that are believed to have deposits, if GRAIL is approved for an extended mission, we will reduce the altitude of the craters, of the two spacecraft, down to about 20 kilometers, so that we will actually be able to resolve small, simple craters on the moon. And if there is enough water ice within the craters or beneath the surface, we may be able to detect that with the GRAIL mission. But that remains to be seen if that's the case.
Okay, we're going to now go to our phone lines and take a few questions there. First up is Denise Chow from space.com. Denise?
Hi, thanks for taking my question. This one is for Maria. I was wondering if you could just talk a little bit about how the mission has gone so far in line with your expectations and how exciting that was for you and your team on New Year's Eve and New Year's Day for both very successful orbital insertions. Thank you.
Sure. Okay, so on the missions, whenever we practice, in all of our practices, everything goes wrong. Okay, and it was just an extraordinary experience to be sitting there and just having everything go perfectly. I say it's something that we never trained for. Is
Yeah,
that
for
when
the
things go
insertion,
right.
for the real insertion. Yeah.
And so the both orbit insertions were precisely where we wanted them to be, and then subsequent to those insertions, the first weekend after we inserted, there were 3 main engine maneuvers to reduce the period of the orbits, where we actually expended more fuel in those 3 maneuvers than we actually did in the orbit insertion maneuver. And those all went successfully. And then the week after that, this past weekend, we did 3 more main engine maneuvers and for the GRAIL-B, a Flow spacecraft now. And all of those were nominal. So far, these spacecraft have operated nearly flawlessly. This is a very operationally intensive mission because there are 2 spacecraft, and I have said to people sometimes, I think I know what it's like now for people who raise twins. Okay, however, they're very well-behaved twins. And actually, their personalities are very similar because the behavior that we see in one gives us a pretty good expectation of how the other one is going to react when we do these maneuvers. So spaceflight is a very risky thing, and whenever you have 2 of something, that doubles the opportunities for things that can go wrong. But so far, so good, and both of the spacecraft have been operating very well, and the team is actually delighted with how things have been going so far. But we're really trying to keep our eye on the ball here because we have a great deal of work to do yet before we start returning science data.
Our last question is coming from Robert Perlman from collectspace.com. Robert?
Hi, thanks for taking my question. Not to take anything away from Ebb and Flow, but for Maria Zuber, if you could comment a little bit about what the competition was. With so many submissions, were there others that stood out? And I think back at the launch conference, you had your own names. Could you share what those were?
Let's see. Well, I had, so the competition, there were over 900 pairs of names that were proposed. I had my own set. Everybody on the team had their own set of names. And none of those names that any of us had were nearly as good as what we got from the students. It actually was, it was very difficult to make this decision. And, what won the day actually was the quality of the essays that the students wrote. So thank you.
Okay, that's going to do it. Nice, short, and sweet. Again, congratulations to the students at Emily Dickinson School in Bozeman and to the teacher, Ms. Tomorrow, Ebb and Flow. Thank you all for joining us here. And of course, to Dr. Sally Ride on our phone and Sally Ride Science. Ladies and gentlemen, the numbers speak for themselves. We inspire students, and we do it, and we will continue to do it. Ebb and Flow, congratulations again, Bozeman. Thanks for joining us, and happy New Year.